Okay, working with quadratic functions, we're doing page 184, number 8, right? Okay, number 8 is a word problem, and it says that target shooting discs are launched into the air from a machine that's 12 meters above the ground. So we know we got some machine sitting like this, and it's firing discs into the air, okay? We also know the height of the machine is at least 12 meters. The height in meters of the disk is h at t after launch is modeled by this function. So our function is h at t, which represents the height of the disk after its launch, is equal to negative 5t squared plus 30t plus 12. Okay. Where t is time in seconds, okay, and t equals our seconds. Now, which form of quadratic are we in right now? Standard. That's right, we're in standard form. So we have our standard form here, and this is actually a good little note we can notice from this. We're going to quickly just make a graph of our own, just as a rough sketch. And we know that, say this was our y-axis, and this is our x-axis. What is our y-intercept in this case, if the disks are being launched at what time, are disks not being launched? Our origin will start at 0, so this would be our t, and this would be h at t, right? Our y-axis is our t, and our x-axis is our t in time. So what's our y-intercept of this equation? 0. Well, we know that it'll be x is 0, but what is the y part? So when will it cross the y-axis? Essentially, what height is it being launched from? 12, yeah. Well, so what they've told us there, that is the y-intercept. And if you notice in standard form, this is our a value, our b, and our c. Notice anything interesting about our c value and the y-intercept? That's right. So in standard form, your c value is always your y-intercept. Okay. So we know that our y-intercept is going to be at 12, and it's going to be some function. Who knows? It goes like this, and it's going to eventually come down and hit the ground. Okay. Now, what the question is actually asking us is they want to know, A, when will the disk reach the ground? So in other words, what are they looking for in terms of a parabola when it reaches the ground? What would this be called? If we called this the y-intercept, yeah, exactly. That's the x-intercept. So we're looking for an x-intercept. Now, because this is a parabola, our a value is negative 5, so we know it's facing downwards, which is roughly the picture we've drawn. It looks like it's going to have 1 and 2 x-intercepts. We're going to have to figure out which one is the correct one after. Okay? So we're going to take that equation, which is our h at t is equal to negative 5. So we have the equation h at t is equal to negative 5t squared plus 30t plus 12. Okay. Now we're looking for an x-intercept. So what can you tell me about the coordinate of an x-intercept? We know an x-intercept. What will the y value of an x-intercept be? 0, that's right. We know for a fact that an x-intercept is going to be when y is 0. So with that information, our y, which is technically h at t here, we're going to replace that with 0. So our new equation is going to read 0 is equal to So 0 is equal to negative 5t squared plus 30t plus 12. Now, from here, to find x-intercepts, what's our process? What form do we want to get into? That's right, we want to get into what we have over here as our factored form. Okay. So the first step to factoring, what do we do? Okay, yeah. See if there's a greatest common factor. Okay. Now, can we take 5 out of all of these evenly? No, we can't do it from the 12. There is a number we can take out. It won't really change the absolute value of these numbers, but it will change their signs. What can we take out of each of these? Yeah, that's right. We'll take the negative out just so it's easier for us to factor. So we're going to take negative 1 from each of these. Okay? So our next line will read 0 is equal to negative 1. What's inside the brackets? Positive or negative? Positive 5t squared
minus 30t.
Yep.
Minus 12.
Good. Okay. Now that we have that, we can use our factoring by product to solve it. So what's my first step?
Find the two numbers that equal to the multiplied by 5.
Yeah, that's right. So we have 1t and 5t. Anything else? No. What about 12?
1 and 12.
Yeah.
2 and 6 and 3 and 4.
Great. And we know that we got to figure out what?
Two numbers that add up to 30.
Add up to just 30?
Negative 30.
Negative 30t. Okay. So quickly looking at this while I'm making boxes, what do you think we're going to end up using? We might have to trial and error. It's tough to look, eh? Alright, let's try to go through this. 1t times 1, 5t times 12, that's going to give us 1 and 60. Any combination of that can make negative 30? What if we go the other way around? No, that's right. 1 times 12 and 5 times 1, that's not going to work for us. So we know this column doesn't work. What about 1 times 2 and 6 times 5? That's going to give us 2 and 30. Is that going to work? No, not quite. Close, eh? 5 by 2 and 1 by 6 is going to give us 10 and yeah. Any combination of that going to work? No, that's not going to work for us. And what about our last one here, which is 1 by 3, 5 by 4? Yeah, is that going to work? No. And what's the other one? 15 and 4. Is that going to work? No, we definitely came up with nothing that ended up working for this factoring style. Okay, so technically when factoring doesn't work, you're going to learn this next chapter. You go to this formula, okay? So I know you haven't seen it yet. It's called the Quadratic Formula. Now that would solve it for us. But in terms of this test, technically she doesn't expect you to know that. I could show it to you. I doubt you're going to run into a question that you won't be able to factor. Another way we could factor is by trial and error. We can plug in values of t until we're above the ground and then below, and we can assume it'll be somewhere in between those seconds. Okay? So you know what we're going to do for argument's sake, because I know she hasn't taught you quadratic formula, we're going to do it by trial and error. Okay? So using trial and error, I'm going to make up a little t chart. So we have our chart, and essentially what I'm doing, my independent variable is the time. Okay? That's my t, or in other words, our x. X is always your independent variable. Our y is h at t. Now, we can be pretty confident that after 1 second, this thing probably isn't going to hit the ground. Okay, so we'll start at 2. Maybe go 3, 4, 5. Hopefully it falls into one of these numbers. Essentially what we're going to be doing, and that number's 2, is we're going to be plugging those into our formula. Okay, so our first attempt, I'm going to call it, remember we did function notation? This is when h is 2. Okay, you remember doing that in chapter 1? So when h is 2, we get 5, 2 squared, minus 30, by 2, minus 12. Okay, so that's what we're solving for, h at 2 here. We'll get 5 times 4, subtracted by 60, minus 12, which will be 20. Oh, look at that. Minus 60, sorry, it's plus 12, right? Oh, yeah, we switched it, that's why. Oh, and this is supposed to be plus 30. And this is supposed to be negative 5. There we go, okay. Sorry, we didn't write the original one. I ended up looking at this one here. That was without the negative 1. Technically, we needed to start with the original, which was the negative 5. Okay? So our answer actually has, wondering why we're already negative. Negative 20 plus 60 plus 12. This is clearly going to be a positive number. We're going to get 40 plus 12 is 52. So we're quite high above the ground in this function notation. What I'm going to do is I'm going to jump ahead a little. Okay? I'm going to try 4. So let's go to h at 4. get the feeling 3 won't be it. I highly doubt it'll drastically change that much. So we're going to go to 4 squared plus 30 by 4 plus 12. The only reason I'm skipping these numbers is, say we're in a test and this is a time constraint, I'm trying to get to the answer fastest. Technically, the most thorough way would be to do all of them. So we end up with negative 5 by 16 plus 120 plus 12. Let's see. Negative 5 times 16. Negative 80. Okay. So we got negative 80. Yeah, we're getting closer. Plus 120 plus 12. Okay. That's going to give us 62? Sorry, no, 52 again. Oh, is it 52 again? Oh, look at that. So what we've probably found, okay, just by deduction, because this parabola we knew went up and then comes back down. We know we're eventually going to hit points that are the same. We've probably come up to 52. We're probably peaked at 3. We didn't find it. It's a good estimate that may be our vertex. We don't know yet. And now we're coming back down. Okay, so I'm going to use a little logic here. I know 1 was in the air, and if a parabola is symmetrical, 1, 2 was at 52, assume 3 is a vertex, we're at 52 again, at 4. 5 is probably going to be equal to our 1. 6 is probably going to be, it might be under, or it might be our y-intercept. Let's figure that out, okay? Let's try that. H at 6, because remember that was our y-intercept before. We started at 12, which is our constant there, so we get negative 5 times 6 squared plus 30 times 6 plus 12. So we get negative 5 times 36. Is it equal 12 in the end? Yeah, it's exactly what I figured it would, because that was our other number, right? So in the end, we end up with 12. So that makes sense because it's symmetrical to our y-intercept. So this is making sense. So let's try a second, essentially after that y-intercept. Let's try h at 7. H at 7 gives us negative 5. Oh, you figured it out already?
Well, that's when you negative 5 times 7.
Oh, okay. Oh, let's make sure we square 7 first, though. Did you square it when you did it? Oh, you did? Okay. All right, so let's do this one step at a time. You're a mile ahead of me. So 7 squared is 49 times negative 5, which what?
Negative
245. Plus 210 plus 12. Quickly looking at this, I know I'm going to have a negative number. Negative 23. Okay, so this gives us an idea. Negative 23 from here. So my x-intercept is somewhere between 6 and 7 seconds. Right? And if our 12 was, our 6 seconds was 12, so I'm going to go back up and try to make sense of this, okay? So this is what we essentially found. We never really found the 1 second mark. 1, 2, 3, 4, 5, 6. Was it between 6 and 7?
Yeah.
Okay, so let's actually, we're going to just remake our graph a little because it turns out we're doing all right. I'm going to just change this a little using the information we had. Now, we never found 1, but we did know at 2, we were at 52 meters, right? And then at 4, we were at 52 meters again. At 6, we were at 12. Yeah. Let's drop this 12 down a little, just so it's. I know it's not to scale, but just so it tries to make sense a little more. 6, we're at 12. We'll say that's where 12 is, and then at 7, we're at negative 23, right? So we're down here, which means at negative 1, in terms of symmetry, we're probably at negative 23 again. So we have some parabola that goes like this. Probably peaks at 3, comes down, and then crosses somewhere between 6 and 7. Okay? And then crosses somewhere between 1 and 0, negative 1 and 0. Our x-intercepts are in that range. Okay? Now, normally they want exact answers, but we haven't learned quadratic formula, so we're going to give it a range on this question for now. And the second part of the question asked us what our maximum height was. Well, we can estimate that maybe 3 was going to be our maximum height. It might be like 3.2, 3.4, 2.8, somewhere in there. But we're assuming our maximum height is somewhere between these 52s, so we're going to estimate it's at the 3. So we're actually going to go ahead and solve for that, okay? Because, again, we can't use our axis of symmetry formula because I actually don't know what my R and S are because I'm just guessing right now, okay? So let's figure out our H at 3. Our H at 3 is probably going to be our vertex. So H at 3, we're just going to do it this way, and then we'll do a quadratic formula to see how close we were. Negative 5 by 9. I should just do that right now. That's going to be negative 45. So we get negative 45 plus 90 plus 12. That's going to give me 45 plus 12, 57. We assume that at 3, we're going to pretend this is our vertex. We might be a little off. 3 and 57. That was our estimated vertex. Now, theirs might be a decimal. That is the answer. So look at that. Our estimate ended up being right. Now, in order to find those actual x-intercepts, because we were unable to factor that, we do need to use quadratic formula. So I'm going to show you the exact way to solve that now. Okay? We'll go to the next page. Okay, so there's our original formula. Now, we were unable to factor it, so what we're going to use is our quadratic formula from over here. Okay? Now, this quadratic formula refers to the form we're in right now. You have to be in standard form in order to plug this in. Okay? So we have our a value, which this is our a. There are two b values we plug into. Sorry, there are also two a values. And there's one c value. And what it is it's solving for our x value, or in this case, that's our t value. And it has to be set equal to 0 in order to get into this quadratic formula. So we get x is equal to negative, now b is 30, plus or minus square root. We know it's going to be divided by square root of b is 30 again, squared, minus 4. Our a value is negative 5, and our c value is 12. Underneath, we have 2 times a again, which is negative 5. Okay? We're going to get negative 30 plus or minus square root. Now, the good thing about learning this is you're going to go into this next chapter, so you got to know it anyways. 30 squared, 900. Now, think of this like negative 4 times negative 5, which will be positive 20. Now, positive 20 times 12 is positive 240. So we put the positive sign there, so it's like plus 240. Okay. 2 times negative 5 is negative 10. Does this ring a bell at all from before? I'm going to just underline this stuff in the color just because I want you to recall this after, so you're not like, where did you get those numbers? Okay. Then we go into negative 30 plus or minus, and it's going to be the square root of 1,140, I think, all divided by negative 10. And then finally, negative 30 plus or minus, now let's double check that, 900 plus 240, that's right, good, square root that. So I'm just going to hit the 1 button, 33.76 I'm going to say, 33.76 by negative 10. Now, if you notice, I have a plus minus sign here. That plus minus sign is because technically the square root of our number, so the square root of 1140, has two answers. It's technically positive 33.76, and the other option is technically negative 33.76. Because if I multiply a negative times a negative, I'll get a positive. If I multiply a positive times a positive, I'll get a positive. So what this is saying is you have two options now for answers. So from there, just like in factor form, we're going to split this into two equations, which makes sense because we know we have two x-intercepts, right? It was a parabola where the vertex was above and it was facing downwards. Do you remember all that? Yeah. It was a long question so far. So we have negative 30 plus 33.76 divided by negative 10. And our other option was negative 30 minus 33.76 divided by negative 10. Okay, so let's figure this out. Negative 30 plus 33.76 divided by negative 10. Negative 0.376. So that's a coordinate. Negative 0.376 and 0. Our other option is negative 30 minus 33.76 divided by negative 10, positive 6.376. Again, we could have rounded this one to approximately negative 0.4, and we could probably round this one to approximately 6.4. So our option would be 6.4 and 0. Now, is that one of our answers?
Yeah.
And it makes sense because we wouldn't go in a negative direction, right? We're looking for when it hits the ground, so we hit the ground at 6.4 and 0. Okay, question 9 on your chapter test. They give you a chart, and it's rainfall and yield. Now, we talked about this before. Independent variable is our x, and the dependent is y. Well, yield of a field, so the amount of food you're probably getting, or how much is growing, is most likely dependent on rainfall. So that will be our independent. So depending on the amount of rainfall will determine how much yield we get. We also know that rainfall ranges from 0.3. I'm just going to quickly put the range in. We know that our x, the lowest value they gave us was 0.3, and it went all the way to the highest value, which was 1.5. So we need some kind of chart, and we usually want it to start at 0. That'll range to 1.5. So maybe I go up by 3s. Let's see, 1, 2, 3, 4, 5. That'd be too easy. 1, 2, 6, 7, 8, 9, 10, 11, 12, 13. Well, I can't go by 1s, but if I do go by 2s, I'm definitely going to encompass my 1.5. So if I start at 0 and I go 0.2, 4, 6, 8, 10, 12, 14, 16, already I'm past it, right? 18. So we know that that's going to be our point right now. And maybe we go to 0.2, 0.22, 0.24, 0.26, okay? So we've written everything we can there for our range. Our y range actually is very large. It goes from 35 all the way up to at least 442. Okay, 442. So we have a range that goes from 35 to 442. That's a very large range. Let's see, I'm probably going to have to go up by 50, so let's make some sense. 50, 100, 152, 253, 354, 450. Yeah, that would probably make sense. Anything else might not fit. So let's do it like that. 50, 150, 250. Now the problem with this is because we have such a jumping range, we won't be extremely accurate. But that's okay because we're going to have to do some estimating in this question anyways. Now, does this make sense so far? Building the chart is actually quite important in this one.
I really hate doing the chart.
Yeah. It takes a bit just to set it up, right? All right, so I got my chart, and I'm going to start plotting my points. The very first point they give me is at 0.3, which would be in between these two. And it's at 35. So if anything, I'm 0.3 and 35. I'm roughly there. 0.45 and 104. So 0.45, that's a little in between that. And 104, we said? Probably just above. Okay, so we have two coordinates. Next coordinate they give us is 6. That's good, we have that number. And 198, which is pretty much 200. I'm going to say it's there. 0.75 and 287. So 0.75 is going to be just before the 8. And what did I say? 287? Somewhere like that. All right. 0.9 and what was it? 348 is just before.
1.05401.
What did I do here? 1.05. Okay, and what was it? 401. Okay.
Then 1.2.
That's good. We got that.
427.
Okay, so it's roughly in between.
Then 1.35. 442.
1.35. 442. That's going to be like about there. And then
150. 1.5.
Yeah.
418.
it's going to be like there. Okay, so we'll try to get some kind of curve of best fit. We go through this. It looks like we're getting to the peak of the quadratic, and then looks like we're on the way down, but they don't give us the rest of the information. So we've graphed what we can. Now, students at an agricultural school collect data showing the effect of the different annual yields from rainfall being X and Y being our yield of broccoli. What is an equation of a curve of best fit? So we've created our curve of best fit. We need an equation of it. Now, we're going to either need to make our equations done. Standard form is really hard to make an equation out of. But if we have x-intercepts, we can use factored form. Or if we have vertex, we can use vertex form. Right? Now, I want to point this out. Even though our curve of best fit pretty much used the highest point as the vertex, remember how we were doing symmetry before? If you noticed, this point here and this point here, they weren't symmetrical, right? So technically, our vertex is probably somewhere even a little higher in there, the real vertex, but we have to estimate. So we can either A, use the exact numbers they have in here, and it looks like it's pretty good, or we can estimate to rounder numbers if we want. Okay? It's really up to you, because there's no 100% right answer to this, but there is a range of where the right answer should be around. Okay? Now, in terms of this, how would you like to go about it? Do you want to use the exact terms they give us? Okay, so then we're going to say that their highest point, we're going to call that the vertex. Okay. Do we have both x-intercepts? Or in fact, do we have any x-intercepts? No. So it's pretty unlikely the other one maybe is around here. We can't really use our factor form. And that's why I pointed out our vertex. We're going to have to use our vertex form in order to solve that. So the vertex they've given us is 1.35 and 442, right? Okay. So we have that. That's our x value and our y value. Or in vertex form, it's our h and our k, right?
And then you just take one random point from the...
Exactly. What random point would you like to use?
I guess the first one.
0.3 and 35. You know what? I like that point too. It's relatively a round one. So we got 0.3. And what was the other value? 35? So they're going to represent in our vertex form the x and the y value, right? So let's go down. Let's get our vertex form out here. Vertex form. There we go. So we got our vertex form. Now we said the h and the k was going to be our vertex that we said from above. So our vertex they'd given us was 442. So that's going to be our x and our y, or our negative h and k. Right? So let's plug those in to start. Y is equal to, we don't have an a value, we don't have an x value yet. All right, our h. They have 1.35, so what are we going to put in for it? Yeah, that's right. We use the opposite. And that's why I was writing a negative h underneath each time, because we know it has to be opposite of what that is, right?
So if that was a negative x, we're going to put
a positive number in there, exactly. What's our k value?
442.
Positive or negative?
Positive.
That's right. Positive 442. We got that. Now our x and y values. We have them right there. We're going to replace the x and the y in the equation with that random point that we got. We know it's on the line. So our y value was 35. It was equal to, we still don't know a. Our x is 0.3 minus 1.35 squared plus 442. Now we got a lot to calculate. 35 is equal to A. What does that become? 0.3 subtract 1.35 gives us negative 1.05 squared plus 442. 35 A. What is negative 1.05 squared? 1.1025 plus 442. Now, before I start dividing stuff, I'm actually going to move the 442 to the other side. So we'll get 35, subtract that amount. We still have 1.1025. What does 35 subtract 442?
Negative 407.
That's A. 1.10. Now, how do I move to get the A by itself?
You divide 1.1025 by itself and then divide on both sides.
Exactly. On both sides, we're going to divide by this amount. What will happen on the right side?
A will be by itself.
A will be by itself. In other words, these two cancel each other out. So what do we get when we divide those terms? Close to 400 maybe?
Negative
369.1.
yeah.
Let's 0.1 something. Let's just approximate A to be negative 369. Okay. So what that means from our formula above, we have y is equal to negative 369 x minus 1.35. That was our h value squared plus 442. I'm just going to double check that number. I think you did have it. 407 divided by, yeah, right on. Okay. So there's our number. Now they may have something that's a little different. Maybe their x value is a little left or right, and y value a little higher or lower, and their a value may be a little higher or lower. But as long as we're around that, we have a relatively good answer. Okay. So they wanted it in standard form, it turns out. So that means we got to expand this. Always remember that to go from vertex to standard, we can expand. So we'll get y is equal to, we're going to stick to our numbers, 369 x minus 1.35 times x minus 1.35. Remember, it's squared, so it's essentially we're going to be foiling the number by itself. I'm going to work with the brackets first. So we'll get negative 369. We'll get x squared minus 1.35x minus 1.35x. Now, we're going to have to figure out what negative 1.35 times itself is. Okay, so 1.35 negative squared is times itself. 1.8 positive 1.8224. Run out of room here. Plus 442. So I just kind of squeezed that in there. Okay. Let's start off equating our terms. 369 x squared. This is going to become minus 270, I believe. 2.7x. And our next step to standard form is distributing. A lot of steps in this question. So negative 369x squared. Now we had 2.7 negative times 369, which was a negative. That was 996.3x. And then 369 negative times 1.8225. 5. Yeah, that's probably right. They got negative 6, 7, 2.5, we'll say. And then we're going to be adding 442 in the end. So our final standard answer will be negative 3, 6, 9x squared plus 9. I'm going to round it to 996x. And we'll round our last part too, because again, this was all an estimate. Plus 442. Let's say negative 230. What was their final answer?